So we learned back in lesson 2. What lesson was that? There it is, lesson 2.2. Back in lesson 2.2, we solved absolute value equations and inequalities. That was lesson 2-2. Here's lesson 2-9, solving absolute value equations and inequalities by graphing. So we're solving the same thing that we solved in lesson 2.2, the exact same thing we are solving. We are just doing this from a visual graphical perspective as opposed to strictly algebra. So I want to remind everybody that when you have an absolute value equation, you will write 2 cases and solve for 2 cases. Because if you have an absolute value equation, everything inside the absolute value could be the positive or the negative version of what's inside that absolute value. You have to write your 2 separate cases. This is also going to be good review for your test next week, because your test will be next Wednesday is when our test is going to be. Because lesson 2.9, by the way, this is the last lesson of the unit. This is the last one. So we're going to start our review on Monday. So 2 cases for absolute value equations, the positive version and then the opposite version, where everything is the opposite, right? 2x plus 13, negative 2x minus 13. And then you solve both cases. And this is the important thing here. Once you solve for both of them, you must check both answers, because not all of the answers always work when you check them with the original equation. So that is something that you're going to need to continue to look into. We are not going to be solving these algebraically today. I'm just kind of reminding you what we were dealing with that. And then we moved on to absolute value inequalities. This is where we use this little table right here. And if you ended up with the absolute value by itself, and it was a less than, or perhaps a less than or equal to, this was an and statement. An and statement meant that the answers that you get, both the regular and the opposite versions, for sure, yeah. So these are going to be going towards each other, meaning the numbers that you have here and here, like let's say it's 5 and 0, the answers would need to be in between 5 and 0, because it works with both being less than 5 and greater than 0 at the same time, like 2. 2 is less than 5 and 2 is greater than 0 at the same time. So that would be the and version, where it is less than. If it is greater than, you might remember, then that means it is an or statement, meaning it's either this or that. So if it was 5 and 0, it would have to be greater than 5 or less than 0, because there is no such number that is both greater than 5 and less than 0. So it has to be one or the other. That's what we talked about with absolute value inequality. And then in terms of putting them on a graph, on a line, on a number line, I should say, it looked like that for an and on a number line, it looked like that right there for an or. If it was an equation, I think we did this as well. Yeah, if it was an equation, it was just 2 dots on the number line. Now, today, we are going to basically be talking about what happens if you have an absolute value equation and you graph the actual absolute value equation and then solve for x. We're still solving for x, right? Back in lesson 2.2, all we did is we solved for x. And we're still only solving for x, but we're using both x and y to solve for just x. I just want to make that really clear. Our answers will only be solving for x, even though we're looking at an xy graph. We're still only solving for x. Serenity, we will need a graphing calculator today. And then just to remind you, this all I guess is just perhaps. Sorry, it's recording, so if you need to kind of, and then I'll go handle that one. Appreciate it. Okay, so we're going to graph using x and y. We are going to solve only for x. Pretty cool with that so far? So it's the same idea that we had from lesson 2.2. However, we're going to look at it from a graphical perspective. And it says the graph of a related function. So remember when we did graphs of related functions for equations, where it was like a linear thing and we figured out where the line crossed the x-axis? That was lesson 2.1, I believe. When we were talking about graphing a related function, here it is. Solution set. No, that's not true. The graph of a related function. Yeah, there it is. So graphing a related function with a linear equation right here, you notice there's only an x, and then we set the equation equal to 0 right here, and then we graphed this line, and we were looking for when this line is 0 on the y-axis, meaning where does it cross the x-axis? So in this case, it crossed the x-axis right there. So we were only solving for x, even though we had an xy line on a graph. We're doing the same thing today with absolute value. So instead of having a line, they're going to be all v-shaped. That's really the only difference. So a related function just basically means you set an equation with only one variable x. You set it equal to 0 because you're still only solving for x. You're not going to have an x and a y, but you're going to graph it as if it was an x and a y. And the graph of an absolute value function could intersect the x-axis twice. 1, 2. So our x-intercepts would be here and here. So there'd be 2 answers to that one. Maybe it only intersects the x-axis once. If the vertex is on the x-axis, that would only be one solution. Or perhaps it's entirely above the x-axis, meaning there's no solution. Or perhaps it's reflected across the x-axis, and it's also entirely below the x-axis. That's a possibility as well. That would also be a no solution because it doesn't come into contact with the x-axis. So those are our 3 possibilities. 2 solutions, 1 solution, no solution. Infinitely many is not an option here. Because if it's a V-shaped graph, there's no way it can be equal to the x-axis. That's not going to happen. So in terms of solving by graphing, you must get the absolute value portion of the equation isolated. So in this first example here, if we're solving this by graphing, we are going to we're actually going to set the thing equal to 0. I should adjust my language on that. We need to set it equal to 0. Now, you don't strictly have to set it equal to 0 necessarily. So, okay. There's actually 2 ways to do this. The book is suggesting, and I agree with the book here, that we should go ahead and isolate the absolute value. Because if you isolate the absolute value, there's less you need to do to actually put it on the graph. Like if we were to use this side, there's more substituting we'd end up having to do. Multiply by 2, add 6, takes the absolute value, add 5. That's a lot more work that needs to be done. So I would suggest what the book is suggesting, and it just so happens that it equals 0 when you get the absolute value by itself. Does that make sense so far? Because if you get the absolute value isolated here, you're going to subtract 5 from both sides. And the absolute value of 2x plus 6 is equal to 0. And so it just so happens that it equals 0. But isolating the absolute value is going to be a good thing to do here. Now, that is something that we certainly can do. And gosh, there's 2 ways to do this. I'll show you both ways. It's fine. This one doesn't really make a difference, but I'll show you both ways on the next example. So isolating the absolute value here or getting the equation equal to 0, those are your options. You could do either way because with so many things in math, you have options. So if you replace f of x with 0, it gives the related function f of x equals what's in the absolute value, which is the absolute value of 2x plus 6. And then what you're going to do is you're going to graph the equation or the function f of x equals 2x plus 6. And if you were to make a table of values to graph it, it's suggesting that we use -6, -5, -4, -3, -2, -1, 0. Now, something that I have not mentioned previously is how you can tell that this is the vertex. Because what they did is they made a table of values with the vertex in the middle and then 3 points on each side of the vertex. How do we know that this is where the vertex is? Because previously I've told you, just use -2, -1, 0, 1, and 2. If the vertex isn't within those bounds, then, choose numbers less than or more than until you figure out where the vertex is, which is effective, but it's more of like a guess and check situation. You can actually know exactly where the vertex is based on the absolute value equation. So the vertex. Let's just go with this. X value for vertex. So to get the x value for the vertex, once you get the absolute value isolated, or you get it equal to 0, you're going to go ahead and get x by itself here. Like solve for x inside of here. So basically, you're going to say 2x plus 6 equals 0, and then solve for x. So take whatever's inside the absolute value, set it equal to 0, solve for x. So if you subtract 6 from both sides, that'll be 2x equals -6. Divide by 2. What does x equal? -3. There's the vertex. X equals -3. So that is a way that you can figure out where the middle of your vertex is going to be. Or sorry, the middle of your absolute value graph. So, and then you can build around that, right? 2 or 3 numbers less than that, 2 or 3 numbers more than that. And then we plug in values for x and we solve for y, solve for f of x. So if you plug in -6, 2 times -6 is -12. -12 plus 6 is -6. The absolute value of -6 is 6. And because we know that the vertex is here, that means that this point is reflected over here as well. So that's also going to be 6. If you know where the middle is, you know that the points going left and right that are the same distance from the vertex are going to have the same y value. So that also makes it a little bit more convenient. There's less math that has to be done that way. If we substitute in -4, 2 times -4 is -8. -8 plus 6 is -2. Absolute value of -2 is 2. And so this other one is 2. So those are our values. And then we can go ahead and plot all those points. -6, 6. Let's go ahead and graph this thing. -6, 6. We've got -5, 4. -4, 2. -3, 0. -2, 2. -1, 4, and 0, 6. So there it is. So in how many places does this graph come into contact with the x-axis? Just one. Yeah. So there's only one answer to this because the vertex is on the x-axis. So it says since the graph only intersects the x-axis at -3, the equation has one solution. The solution set is -3. Now, if you wanted to, you could just say x equals -3. I'm cool with that. That's fine. And if there's 2 answers, you can say x equals -3, comma, whatever the other number is. So that is the basics of solving an absolute value equation on a graph. Put it on the graph, figure out where it comes into contact with the x-axis. Questions before we look at the next one? All right, so let's keep going. Now on this one, I'm going to show you both options because we actually do have 2 options for graphing this. So I'm going to have to use a couple of different colors here, but part A says to graph the related function. So in terms of what it told us to do on the previous page, it said rewrite the equation with 0 on the right side. So let's do that. So if we're going to rewrite the equation with 0 on the right side, that means we need to subtract 13 from both sides, right? To get 0 over here, we need to subtract 13. So what is 9 minus 13? -4. Okay. So the related function, the first option for the related function is f of x equals the absolute value of x plus 1 minus 4. So let's do that one real quick. Where is the x value for the vertex? If you take what's inside of the absolute value bars and you set it equal to 0 and you solve for x, where does that put the x value of the vertex? At -1. Yeah. So if we want to do a table of values, I would say, let's do x values here. And again, I'm going to keep this in red. We're going to do -3, -2, -1, 0, 1, and 2. Or just 0 and 1. That's fine. We'll do 2 on each side. 0 and 1. We'll just do 5 points. All right. And then our y values. Somebody needs to fix their exhaust. Okay. -3 plus 1 is -2. The absolute value of negative 2 is 2. 2 minus 4 is negative 2. Which means that if we plug in 1, we're also going to get negative 2. If we plug in, I'm going to need to get some lines on here. There we go. If we plug in negative 2, negative 2 plus 1 is negative 1. Absolute value of negative 1 is 1. 1 minus 4 is negative 3. So we've got negative 3 here, and we've got negative 3 here. And if we substitute in negative 1, that's a 0 there, and 0 minus 4 is negative 4. So the vertex is at negative 1, negative 4. All right. So if we go to negative 1, negative 4, there's our vertex. And then if we go to negative 2, negative 3, that's here. And then 0, negative 3 is here. We can just kind of bounce back and forth as we move out. Negative 3, negative 2 is here. And 1, negative 2 is there. Which means if we keep going with this same pattern, we can see it's going just a 1-to-1 as we go through here. And so we can keep going just like that. And this will be our absolute value graph right here. So in how many places does this cross the x-axis? 2. All right. Where? Negative 5 and 3. All right. So the solution set, we would say, would be x is equal to, we can just do negative 5, comma 3. We'll go ahead and put it in braces because that's the way we'd write a solution set. So that's the way that it taught us to do that on the first page, which is perfectly fine. Now there is another option here. The other option is going to be actually what we're going to do for our next one using the calculator. But what you could do is you could just keep it, like this and just graph it like that. Or you could go ahead and just get the absolute value isolated, which would be another option. So that's kind of the other way that I would do this is I would go ahead and say, all right, if I isolate my absolute value, I would actually subtract 9 from both sides. Because if you isolate the absolute value, it's going to make the math a little bit easier to figure out how that absolute value looks. And so what you can do is you get, you subtract 9 from each side, right? And so you would have the absolute value of x plus 1 is equal to 4. Everybody okay with that? Absolute value of x plus 1 equals 4? Because if we subtract 9, that isolates the absolute value. And then if we look at each of these as its own function, meaning, let's say g of x is equal to the absolute value of x plus 1. And then we've already used f of x. So let's say h of x is equal to 4. So basically, we're looking at making each side of the equation equal to a function. This is one function. That's another one. This one is absolute value, so it'll be a v. This one is just equal to a number. So if y equals 4, what does that look like on a graph? That's a horizontal line at 4. So this is the horizontal line at 4, and this is a V-shaped graph. So let's get this on there. So let's go up to 4 and put a horizontal line. So we got 1, 2, 3, 4. So there it is there. And I'm just going to go ahead and grab my ruler, draw my line across. And this is one of the cool things that I like about so much of what happens in math is that there's just a lot of different options for solving things. So what we're going to do is we're going to try to figure out for what values of x over here create y values of 4 over here. So we're basically resetting the intersection point. So instead of the intersection point being on the x-axis, the intersection point is now at y equals 4. We're just moving, basically just moving the graph up 4 to figure out where it crosses across this line as opposed to across that line. And we should get the same answer for negative 5 and positive 3. So we're still going to have, if we get x by itself from within the absolute value, we still get negative 1, right? To isolate that. So if we make another table of values here, we're going to have an x, we're going to have a y. So we're going to use the same values here. We're going to say negative 3, -2, -1, 0, and 1. But this time our y values are going to be a little bit different. Sorry, my blue pen's not working very well. -3 plus 1 is -2. The absolute value of -2 is 2. So this time y equals 2. -2 plus 2 is 0. So that's going to be 0. Oh, wait, hang on. -2 plus not 2. -2 plus 1 is -1. So that'll be 1. -1 plus 1 is 0. And then we're going to have 1 here and 2 here. So let's get our vertex on there. -1, 0, which is right there. And then it's going to have the exact same shape as the red one. It's just going to go out by 1 every single time. And if you end up graphing this, we are now looking for not where it comes into contact with the x-axis, but where it comes into contact with the number across from it, which is a y value of 4. And it's in the exact same place as where the red one crosses the x-axis, which would be at -5 right here and +3 right here. Exact same answers. So x equals -5 and 3. So there are different ways to solve the same equation. You could set it all equal to 0. If you set it equal to 0, what you're going to be doing is you're going to be looking for the intersection on the x-axis every single time. And so a lot of people will choose that because if you're strictly looking for an x-intercept, it makes that process consistent every single time. However, it is okay to answer it like this, where you're not figuring out the intersection of the x-axis anymore. You're figuring out the intersection of when y is equal to 4, as opposed to when y is equal to 0. It just moves up that point of intersection, which can change things for every single problem, right? That intersection point, that 4 could be a different number every single time if you don't set it equal to 0, which is why it's showing you to set it equal to 0. But the reason why I showed you that is because the next example tells us to write 2 separate equations and then solve it using our graphing calculators. So I just wanted to let you know that with your graphing calculators, you can set it up just like we did with the blue one. You could also get the whole thing equal to 0, just like we did with the red one, and solve it either way on your graphing calculator. So we have options here. So fire up your graphing calculators. Here we go. Using technology. So it says, use the graphing calculator to solve this equation. Rewrite this as a system of equations. F of x is equal to the left side of the equation. G of x is equal to the right side of the equation as 2 separate functions. So go to your y equals menu. If there are any equations in there, clear them out. And so we're going to say 4/5, which if you remember to get to the fraction button on your calculator, you're going to click on the math button right underneath the green one, and then you're going to scroll all the way over to the fraction option, and you're going to choose the first one and over to D, and you're going to type in 4/5. Then scroll to the right. Once you have 4/5. From there, we need to get absolute value. So go back to the math button underneath the green one. This time we're just going to scroll over to num, for number. And ABS option 1 is absolute value. That's going to get your absolute value bars. X minus 1, your X button is the one to the right of the green button. It's this XT theta N button. So there's X and then -1. Scroll to the right to get outside of the absolute value, +8. That's the first equation you're going to graph. So hit enter. That's the first one. The second one is just y equals 11. That's it. So hit the graph button. And for most of you, you're probably not going to be able to see the g of x equation. You're probably just going to see the bottom of the f of x equation. So if you notice down here, every single time it's going to tell you the window settings. So this is saying that the x-axis is going from -10 to +10, and they're going up by 1 each time. This is saying that the y values are going from -5 to +15, going up by 1 each time. So let's adjust our window to be able to see where y equals 11, because that's above. It's up here somewhere off the screen right now. So push the button that says window. X minimum, -10, that's what we have here, so keep that. X maximum is 10, keep that. Scale is 1, keep that. The y minimum, on the other hand, we need to change from -10 to -5. And remember, your negative button is down by the decimal. It is not the same as the -1, so -5. And then just hit enter. And then the maximum y value is 15. And then the y scale is the same, so we can go back to the graph now. So once you have those values in there, hit graph again. And now it should look exactly like what we see in our books. There it is. All right. So the window? Yeah. So window, the x values, keep them the same, -10, +10, x scale 1, that's good. And then change the y minimum to -5, change the y maximum to 15, and then keep the scale at 1. So once you go to -5 and 15, just go ahead and hit graph again. And then, does anybody remember what function we're looking for to solve this? What are we trying to figure out here? We're looking for the x values of where the lines intersect. So we're looking for the intersection here and here, and just the x values of those intersection points, because going back to the beginning of the lesson, we are only solving for x. So let's go to our calculation menu, which is the blue calc right here. So you're gonna hit second, and then the trace button to get your calculation menu. Option 5 would be the intersection. Now it's going to ask you first curve question mark, and what you need to do, because we're looking for, there are 2 points of intersection on here. We need to get as close as we can to that point of intersection we want first. So I'm going to scroll to the left a little bit to move that a little bit closer so the graph or the calculator knows that I'm looking for this point of intersection and not that one yet. So I'd say that's close enough. I'm just going to hit enter. And then over here, that's close enough as well. I'm going to hit enter again. And then it should automatically say, it'll say guess, and then it's just going to snap to the left a little bit and give us that one right there. And the x value, we're only looking for the x value here, is -2.75. So that is one of our answers. So we've got a -2.75 to get the intersection. All right, let's do it for the other one now. Hit second, the blue button, and then hit the trace button, and that'll take you to the calculation menu. So second and then trace, it'll give you some calculations you can choose from, and we're going to choose number 5, intersect, because we're looking for where 2 of the things intersect, they cross. And so for the first one, you're going to get as close as you can to this point over here. For the second one, I'm going to scroll to the right to get as close as I can to the one over here. So I'm just going to push the right button a bunch of times, or you can hold it down and it'll just kind of travel. And so you're going to get it as close as you can, or at least close enough that the calculator's going to understand that you want that one and not that one. So you hit enter, and then hit enter again, and then hit enter again. So enter 3 times, and your book actually says that. Hit enter 3 times. And then the other one is at +4.75, and we're only looking for the x value here. So 4.75. What's that? All right, I'll come help you. So 4.75. So the set would be -2.75, 4.75. All right. Once we have that one, I want you to try this next one down here on your own. Do the check step on your own. Yeah, that's good. Hit enter. Yeah, it's going to go on both. Yeah, so hit enter again. You're doing it right. And then just hit enter one more time. So you have to hit enter 3 times. There you go. Yeah. Very negative. There, and just go back. Keep going. Okay, we'll stop there and then go back to second calc. And then second, calculation. And scroll over here. Go over here. Yeah. Cool. Hit enter. Again. Again. All right, so try this one on your own. Take a minute or 2. Shouldn't take too long. Just type them in, see where they intersect. You might need to adjust your window again, because this one right here, that's down at -10 on the y-axis. So you're going to need to adjust your window to be able to see this. That'll be below where it's visible. So give that one a look and see what happens. By the way, is that absolute value something going to be different about that absolute value equation than the first one? How is it going to look different? The absolute value, what does that mean? It's upside down. That is a reflection in the x-axis. Because it's upside down. Question? Oh, okay. I'll be right there. I just realized I have not yet taken a time. Let's see. Oh. Okay. Yeah. Let's find out. X plus 5 minus 15 negative 10. Change the window. Let's see. X minimum to maximum should be fine. I'm going to change my Y minimum to positive 5 and my Y minimum to negative 15 and my Y maximum to positive 5. Yes.
I have set my thing to the one in
Why might that be? So do we need to change our windows even more? Oh, yeah, I zoomed out even more. There it is. That's because, by the way, if you think about this for a second, if only one of them graphed and you went down to negative 15, what does this number right here suggest? That negative 16 with the absolute value outside the bar, what does that mean? It's gone down by 16. So if you only go to negative 15, this one starts at negative 16. And then Lilia, you said, what about the answer? Why not? They don't intersect. Yeah. What? Is it there though? Is there blue?
No.
There's no blue.
No blue.
How far down is it?
Like.
There's no negative in front of your actually value. Oh, we wrote a negative 16 instead of minus 16.
Oh.
There we go. Ah, all right. These calculators are very picky about typing things in. What the heck? Okay, hang on. Let's see. Well, now let's plot down the number after 12. All right. This one has no solution, by the way, because they don't intersect. Question, Julia. Yeah. So let's get a Y minimum. Let's get it to negative 30. And then Y max is negative 10. Okay. There it is. Let's look at this right here. That negative 18 is this absolute value graph. And so it wasn't showing both. Oh, weird. That's odd. All right, no solution. Because they don't intersect. All right. let's check out this one. So, solve. All right, we're getting this thing equal to 0. That's definitely what it appears that we're doing here. So if you subtract 9 from both sides, what's 14 minus 9? And then negative? Wait, yeah. Okay, so negative 5/3 then. Okay. Question here. We're not even going to graph this one, by the way. Well, we will graph it, but like we can answer this right now. The answer is no solution. Why? How do we know before we even graph this that it's no solution? Absolute value cannot equal a negative number. Right? If you take the absolute value of something, it can't be negative. That's not a possibility. So, because the absolute value of a number is always positive, is the word here, or 0, it could be 0. It cannot be negative. Absolute value must be positive or 0. The sentence is never true, so the solution is no solution. You know what? We're going to take a look and I'll show you what this one looks like because it's on the next page. But it basically just looks like the one that we just did up here because they never intersect. So let's take a look. Use a graphing calculator to check. I'm not going to have you graph this one because it's right here. But right here, it shows that if you graph f of x is equal to negative 3 times the absolute value of x plus 7 minus 5, that's this right here. And then it says, let's see, minus 5. Wait a second. Rewriting. Okay, it's getting it equal to 0. So it's doing it the other way. So it's getting the whole thing equal to 0. So it's comparing it with the x-axis this time. And since this absolute value function does not come into contact with the x-axis, there's no solution. So, so it confirms, use the zoom, since the related function never intersects the x-axis, there are no solutions. This confirms that the equation has no solution. Great. So that's what we got for that one. Now, that was absolute value equations. Now we get to talk about absolute value inequalities. We got not a whole lot more to go through. Now, this one is going to be a little bit different. And this one will have the same options as absolute value inequalities as we had before, the and versus the or. There will be either values in between 2 points and, or there will be values outside of 2 points, or, depending on whether or not we're talking about greater than or less than. So the related function of an absolute value inequalities are found by solving the inequality for 0. So get it equal to 0. Replace the inequality with an equal sign. And replacing 0 with f of x. So basically get it equal to 0 and write a y equals equation, just like we did before. You have to keep in mind the absolute value symbol, though, when you actually answer the question. So it starts off, what this basically is saying, it starts off identical to this kind of stuff here. Get it equal to 0, graph the equation, and see what the equation looks like. So that's how we start these. So for less than or equal to, identify x values for the graph of the related function lies below the x-axis. We'll talk about that when we get there. Less than just means below the x-axis. Less than 0, think about this. Less than 0 on the y-axis is underneath the x-axis. Greater than 0 on the y-axis is above the x-axis, right? Greater than would be above the x-axis, less than is below. We are still only answering for x, though. Even though we are using y to figure out what x is. That's what's happening here. For less than or equal to, you include the x-intercepts because it could be equal to. For greater than or equal to, you identify the x values for which the graph of the related function lies above the x-axis. For greater than or equal to, include the intercepts because you're including those points. So let's start with this one right here. I'll tell you exactly what we're talking about. So solve an absolute value inequality by graphing. Here we go. We're going to go ahead and graph this. Again, we can figure out where the vertex is, because if you set this equal to 0 and you add 9 to both sides, that'd be 3x equals 9. 9 divided by 3 is 3. So the x value of the vertex is 3. That's how we got 3 in the middle of this table. So the solution set consists of the x values for which the graph of the related function lies less than below the x-axis. So we're looking for all x values of the absolute value graph which are underneath the x-axis, negative y value. That's what we're looking for. So let's get some points on here. We already have 1, 0, so let's get that on there. There's 1, 0. We have 3, negative 6, 2, 3, 1, 2, 3, 4, 5, negative 6. We have 5, 0. That's right there. So let's go ahead and fill out the rest of this table here. If x is 0, 3 times 0 is 0. 0 minus 9 is negative 9. The absolute value of negative 9 is 9. 9 minus 6 is 3. So 0, 3. Which means we also have the point 6, 3. So 0, 1, 2, 3. 6, 1, 2, 3. A couple other points there. And then 2. 3 times 2 is 6. 6 minus 9 is negative 3. The absolute value of negative 3 is 3. 3 minus 6 is negative 3. So we get negative 3 here and negative 3 here. So that would be 2, negative 3, 1, 2, 3, and 4, negative 3, just like that. Now, we'll go ahead and use a ruler this time because these are a little bit more spread apart than what we've been seeing. Looks like that. Like that. All right. Now, where on this graph are the y values below or equal to 0? Because we're looking for less than or equal to 0 here. So we're looking for all y values that are underneath the x-axis. That would be everything between this point here and this point here. And I'm going to go ahead and draw some red in between there like that. Everybody see what I'm talking about? Every value on this absolute value graph, every point on this graph is below the x-axis between here and here. Where is the graph negative on the y-axis? Well, it goes negative here, it's still negative, and then it's not negative anymore. So it's between those 2 points right there. This is 1. That is 5. So that means that the graph is negative between the values of 1 and 5 on the x-axis. Because these are going towards each other, this is an and inequality. So the solution set is all values of x such that 1 is less than or equal to x, which is less than or equal to 5. Or, if you prefer interval notation, you would say bracket 1, comma 5, and then close it with another bracket. We're using brackets and not parentheses because what? Would be equal to, yeah. If it was just less than, we would have parentheses here. This would be the same, except there wouldn't be lines underneath the inequality symbols. So it's the same type of answer that we got previously, but now we just are taking a visual approach. All right, questions on that? Okay, let's do the last little bit here. Here's another one. Solve and graph, or graph and solve. Let's get ourselves a table of values going. So we're going to graph the equivalent equation and then use the inequality to figure out, are we looking for points that are underneath the x-axis or above the x-axis? This says less than or equal to 0. Less than or equal to 0 on the y-axis. Is that above the x-axis or below the x-axis? Below, yeah. So below the x-axis here, where is the vertex for this absolute value? What x value is the vertex? 2. Yeah, set that equal to 0, solve for x, add 2 to both sides, x equals 2. So the vertex, the middle of our parabola, or not parabola, the middle of our absolute value is at 2. So I'm going to put 2 in the middle and then have 1 and 0 here and 3 and 4 over here. So 0, 1, 2, 3, 4. We know that 2 is in the middle. We can do the vertex first. 2 minus 2 is 0. 0 minus 3 is -3. So we have the point 2, -3. That's our vertex. So 2, 1, 2, -3, 1, 2, 3. Right there. 2, -3. If we plug in 1, let's just do 1 right here. 1 minus 2 is -1. The absolute value of -1 is 1. 1 minus 3 is -2. So we have 1, -2, which means we have 3, -2, which would be here and here. And if we plug in 0, 0 minus 2 is -2. The absolute value of -2 is 2. 2 minus 3 is -1. So 0, -1, 4, -1. That would be here and here. And I'm just going to keep going all the way as far as I can go on both sides with the points. So we'll get everything lined up. You can just follow the pattern once you get a few points on there. You don't need to keep going with plugging in numbers because the pattern will continue. So here and here. And once again, we are looking for values that are below the x-axis, but we're only answering in terms of x. So you're still looking for your x-intercepts, which are there and there. And we are looking for all points on this graph below the x-axis, which would be between those 2 points. Because the graph goes underneath, goes negative on the y-axis in between -1 and +5. So our answer would be all values of x. So we're just going to use we'll do set builder and interval. So we'll say all values of x such that -1 is less than or equal to x, which is less than or equal to 5. There's our set builder. Or we could say, using interval notation, bracket -1, comma 5 with another bracket, because once again, we are including those values. Oh, part B, what is the solution set? Sorry, I guess we could have written the answer there. Oh well. But there's our answer. Any questions on that so far? Now, it is possible to have no solution. I'm just going to go ahead and say that because you don't need to write this down. But for example, if we had a graph, an absolute value that looked like this, does that graph go below the x-axis? No. So if it looked like this, there would be no solution. However, what if it looked like that? What would we say? What's that? It'd be infinitely many, right? What values of x are underneath the x-axis? All of them. So this would be infinitely many solutions. This would be no solution for that particular case. So you have to pay attention to what this is asking you. And you need to pay attention to where the graph is in order to get your answer. So let's do one more. Let's use the graphing calculator one more time. And this says to use a graphing calculator to solve where the absolute value of 5/7 x plus 2 and then -3 is greater than 0. So I'm going to head on back here to my y equals, delete that, clear that out. All right, math, number, absolute value, math, fraction, n over d, 5/7. Scroll over. Don't forget the x. Plus 2. Scroll outside of the absolute value, -3. We are not going to be graphing an inequality on our calculators. We're going to be graphing an equation, just like we normally would. And let's go ahead and reset our window here, because this one is just going with -10, +10, -10, 10. This is the normal window. So what you can do on this one, instead of typing in all those numbers, you can click on the button that says zoom. Click on zoom, and then go to option 6, Z standard. The standard window is -10 to +10 on the X and the Y axis. So Z standard. That doesn't look quite right. What's going on with that? What did I do? Oh, I wrote 5/2, not 5/7. Okay. 5/7. Let me fix that. There it is. That's much better. Okay. 5/7, not 5/2. So, by the way, that would be, it's getting closer to the x-axis and the multiplication's happening on the inside, which would be a horizontal stretch, right? Multiplying by a number inside the group, that number is less than 1. 5/7 is less than 1. That is a horizontal stretch because it's getting closer to the x-axis. That 5/7 right there, horizontal stretch. We also have a translation of 2 units left and 3 units down. There are no reflections because there's no negatives, just kind of reviewing some stuff we talked about in the end of unit 1. All right, what we're looking for here are every place on this graph where the y values are greater than 0. So this time we're looking above the x-axis. So if we use, I'm going to go back to the calculator in a second, but in terms of the visuals here, we're looking at there, we're looking at there, and I guess I shouldn't have filled those in. So open circle, because we're just strictly greater than this time. And then we're looking for above the x-axis, so that's going to go this way. And over here, that's going to go that way. This is an OR. There's no such number that can satisfy both of those things at the same time. This will be an OR situation. It will either be values less than this or values greater than that. Let's find out what those values are. Does anybody remember how to find out an x-intercept? I'll give you a hint. It's on the calculation menu. So let's go to the calculation menu. Which one of those is the x-intercept? Second and trace. Same thing we did earlier to figure out the intersections. Yeah. How do you find an x-intercept? Because we're not finding the intersection of 2 lines here because there's only one function on the graph. We did this back in unit 1 briefly. So if you don't remember, that's okay, but what's another name for an x-intercept? A 0. So we're looking for the zeros of the function. X-intercepts, zeros, same thing. So left bound, remember this is where we have to go to the left of the x-intercept. So we're going to go to the left of that x-intercept. We're not going to go to it exactly. We're going to go to the left of it. And then we're going to hit enter. And then we're going to go to the right of it. It's saying right bound. So we're looking for a boundary on the right. So we're going to go to the right of that intersection. And we're going to hit enter again. It will then ask you if it's okay to guess, and you'll say yes. And then it's going to give you -7. So one of our x-intercepts, the zeros, oh yeah, look at that right there. It says 0. And it also says to use the 0 feature from the calculation menu. So there are reminders in your notes, which is good. -7 is one of our zeros, so put that in for the first one. And let's figure out where the other 0 happens to be. So we're going to go back to the calculation menu, second trace, calculation menu, option 2, the zeros. This time our left boundary point is going to be over here ways. And I'm going to choose a point just to the left, which will be about there-ish. Hit enter. Scroll to the right. We've got a right boundary point. Hit enter. Yes, sure. And 1.4. So the other x-intercept is at 1.4. So the graph lies above the x-axis. That's what the red circles and arrows are for here. When x is less than -7 and when less is greater than 1.4, it should say, I'm going to say or. I don't like that it says and or. Oops, you can't even see that. Or. So the solution set is x is less than -7, or there it is, or x is greater than 1.4. I want you to try that last one on your own. Use the graphing calculator for it. You're looking for the x-intercepts again. And once again, you're looking for where it is greater than 0, so above the x-axis. By the way, for the fraction on this one, you don't have to use the fraction. You could just do 0.5. If you want to use the fraction, you can. But if it's a nice decimal, you're always welcome to use the decimal. Is that what the graph looks like on your calculators? Make sure I type it in correctly this time because I did not on the last one. All right. And then let's see, calculation, 0. Left, right, guess, negative 2.75. So we're going to have x. All right. X is less than negative 2.75 or x is greater than 2.25. Good. Cool. All right. That's it for unit 2. We're done with unit 2. We got about 10 minutes to work, which is good. Your assignments. Most of these, honestly, most of these use graphing calculators to solve. So you are welcome to use Desmos. Desmos does a great job with this as well. We're going to do 1 through 41 odds. Now, as this is the last lesson in the unit, and your test is going to start next Wednesday, this will be due on Wednesday. Okay, you got some time to work on this one. So it's quite a few questions. You don't have to do a lot of graphs by hand. There are some, but not very many. Also, if you need to speed up your graphing process and you have one of these available, you can push second. Everybody keep your graphs on there right now. Push second and then push the graph button, and that'll take you to a table of values. So if you want to make a graph on paper, you can actually just use the table that's on the calculator to make your own table of values because it's already calculated for you. And I'm pretty sure Desmos has something similar to that too. So that might speed up the actual graphing process if it tells you graph on paper. So for the first ones, you need to graph them yourselves. Example 2, you don't need to because it says use a graphing calculator. For these ones, solve them algebraically. Use a graphing calculator to check your solution. So you don't need to graph those either on paper. Those ones you do. These ones you don't. So there might be 6. There's going to be probably 9 graphs you have to make yourself. Yeah. So, a lot of them are just using graphing calculator or graphing software. Desmos is fine too. It does a great job. And in a lot of ways, Desmos is actually a little bit more user-friendly. For example, let me just go ahead and open it up here. because it works on your if you want to use your phone for it, you're welcome to do that. Let's see, Desmos calculator, and it functions real similar to your graphing calculators here. So if we did number one real quick, we have absolute value, which is just a button right down here above ABC. So there's our absolute value, and there's x minus 4. And then we're going to head outside the absolute value. We're going to say equals 5. Now, here's the nice thing about this is that if you actually type in that equation, it'll give you a couple of vertical lines, which basically tells you where the intersections are on Desmos. So that is, let's see if we can zoom in a little bit. And so we got an answer here of -1. I'm not sure why it's not really helping out very much here, but oftentimes you can actually click on it and it'll tell you what coordinate you're looking at. I don't see why it's not doing that here, but -1 for sure. And then over here, we've got -9. So -1 and 9 are the two answers for problem number 1. Now, if it says to solve it by graphing, it does want you to go ahead and actually write the equation, the equivalent equation. So you'd have to subtract 5 from both sides. So you'd end up with x minus 4 and then -5 equals y. And then you can zoom out. And then you can take a look at the absolute value graph. It'll look like that. And then this one will actually give you intersection points there. You can see -1, 0. And then over here, you can hold on that one. That's 9. So you're welcome to use software to help you with the graphing. That doesn't bother me. At this point, we've done enough graphing by hand that I trust that you're able to do that. So there you are.